Hey guys, okay, so we are going to do washers today. So I just posted homework. You'll see homework for 8 to day 1 and day 2. So you want to do that after this lesson because I think there's a couple discs, a couple washers, and then a little bit more of both. Okay. All right. So yesterday we talked about discs. Now we're going to talk about a washer. So looking at a washer, you guys, let's go up here and let's draw a washer. And if you guys back in the day in geometry, you wanted to find the area, right, of that shaded region, what you would do is you would take the area of the big guy minus the area of the little circle, and you would get the shaded part. Okay, so it's all of this part we're looking for. Well, so what we have to do is just have a capital R for a big radius and a little r for a little radius. And we'd say, well, it's pi times capital R squared minus, pi r squared minus pi r squared. And you can see you can take a pi out, and what's left is capital R squared minus little r squared. So that's the only difference, and you can see that this should look real familiar after yesterday's notes. It's just pi r squared, but just has two r's. Okay, all of the steps I taught you, right? The process, all the procedures, everything stays the same. So let's jump in. So find the volume of the solid bound by square root of x. The x-axis, the line x equals 4, but we're going to spin it around the y-axis. So we've got y equals root x. We've got the line x equals 4 right there. We've got the x-axis, and so that's our region. And we're going to spin it, though, around the y-axis. And you can see, right, again, I'm not going to draw the complicated drawing. If I do the complicated drawing, which you should stay away from doing, spin it that way, this guy is going to get reflected. And it's going to spin like this, right? And you have this gap now in between your region and the axis of rotation, right? So if I take a snapshot, if I take a big knife and I slice this solid, and you look right here, there's your washer. Okay, so it's not solid discs that we're going to be adding up. It's going to be these things that we call washers. Okay, but again, what you guys are supposed to do is trust in the process. You draw your region, you draw your spinning guy thing, and that teaches you to start on the spinning guy just like yesterday and go to the region. The first part of the region you hit is going to be your little r, and then the second part of your region is going to be capital R. Okay, and just like before, we write down r equals and r equals. So the only difference is we have two r's. Everything's the same. You see a line segment, you know for sure that this thing is right minus left, and this guy is right minus left. Okay, so right here, if y is equal to root x squared both sides, and x is equal to y squared. Okay, so to get little r, I do right minus left. This is the line x equals 0. So right minus left would be y squared minus 0, which is just y squared. And capital R is right minus left. This is the line x equals 4, so it's 4 minus 0, which is just 4. After you get your r's, your volume is the integral, pi times the integral. Again, there's pi's because we're dealing with circles. Right? Pi times capital R squared, which is 4 squared, minus little r squared, which is y squared squared, dy. Everything's in terms of y. What's our lowest y value? 0. What's our highest y value? Well, when x is 4, the square root of 4 would be 2. So I go from 0 to 2. Okay, so pi integral 0 to 2 of 16 minus y to the 4th dy. And for sake of time today, and just to mix it up from yesterday, let's math 9 all these. So math 9, we're going to go from 0. Oops, I'm going to insert a pi here. So from 0 to 2 of 16 minus variable to the 4th d variable. And you get your answer, 80.425. Okay. On the AP exam, you guys, just so you know, this shows up all the time. It's always there. If you have any bounds correct with a coefficient, anywhere on the problems you get a point. So you get a point for 0 to 2 and pi. If you wrote the correct integral down, you get another point. And if you got the right answer, another point. So just getting one of these parts, you're already at the average. Right? These end up being people's favorites. Not everyone, but I think usually my students, because of the process we do, they at least have a game plan on how to start them. Okay. All right, let's do it again. So we've got a y equals x squared this time. We've got the x-axis, which is down here. We've got the line x equals 0, which is right there, and the line x equals 3, okay, which is right there. And we're going to spin it around the y-axis again. Okay, so y equals x squared, x equals 3, x equals 0. There's our region. We did our spinny guy, and then we start from the spinny guy axis to the first part of the region, little r, from the axis across, capital R. What are those things? Both of those things are line segments. Line segments in calc is either right minus left or top minus bottom. Anytime you want to know how long that is, it's right minus left. Well, y equals x squared is the same as x equals square root of y. And so right minus left here would be square root of y minus 0, which is just root y. Capital R is right minus left, 3 minus 0, which is just 3. You go to your volume equals pi integral. The lowest y value is 0 up to, if this is x equals 3, and I plug it in, I get y is equal to 3 squared, which is 9. So I'm going from 0 to 9 of capital R minus little r squared dy. Again, jump in math 9. Let's put our pi in there. Pi math 9, 0 to 9. 9 minus root y squared is just variable, 127.235. Okay. And just to pause again and to show you the visual, what are we doing? The math is simple. The visual is pretty crazy. What you guys are doing is you're taking this concept that I have this solid region right here. And when I spin it, it gets reflected, right? And it's spinning around. So this is looking like this solid shape is coming out, right? All the way around here. So at any point, you have these things that we call washers, right? And what you're doing, you guys, is you're finding the area of every single one of those washers from 0 all the way up to 9. This little guy way up here has a huge hole in the middle of it. It's a real thin washer. At the very bottom, it's super thick. And you're just integrating it, and you're adding up a bunch of pi r squareds minus little r squareds, which are washers. And volume, by definition, is the integral of area functions. Okay. All right. This guy's a little different, so that's fun because it get kind of boring. It's so easy. So let's go. We got square root of x right here. X-axis, the line x equals 4 right there. And then we're going to spin it around this line y equals 6. Whoa. So if x is 4, this guy's 2. Let's come up here, 3, 4, 5, 6. This is where you stop believing in my process, but my process always works. You guys should have confidence. I'm not going to set you guys up for failure. You draw your region, right? Your two-dimensional region. You then draw your spinny guy. The spinny guy goes around the axis of revolution, which is way up here. And what I tell you guys always is your radius starts on the axis of rotation. That's why you draw the spinny guy to the first part, little r. All the way across it to the other side of your region, capital R. And then you say, well, I know what those things are because Carpenter told me line segment. It's either top minus bottom or right minus left. Little r is top minus bottom. This is the line y equals 6. This bottom one is y equals root x. So top minus bottom is simply 6 minus root x. This top minus bottom, capital R, is 6 minus, this is the line y equals 0. So that's just 6. Just follow the process. Pi integral, right? Now we're top minus bottom, so everything's x's. So we're going from 0 to 4. 0 to 4, capital R squared minus little r, quantity squared. Okay? Grab your calc, put a pi in there. Math 9, 0 to 4 of 36 minus the quantity 6 minus the square root of x, quantity squared with respect to x. And you just found that very quickly, very easy. Answer 175.929. And the graph of that guy looks even crazier. Right? So what's happening? What's actually happening is you're taking this guy, you're spinning it around that line. So you're going to come all the way up here, right? You have that thing and you're spinning it. And so this thing, any place has all these washers that you're adding up this way, dx. Cool. All right, there's one more. I think we're good. Again, it loads up so much faster if I don't take too much time. You guys should be good to go. So that's basically 2 sections. The last section is going to be volume again, which we know it's just the integral of areas. But instead of adding up a bunch of circles, we might have to add up a bunch of squares or right triangles or equilateral triangles. It's all the same stuff. You just need the area formula and you integrate it. Okay, guys, take care.